Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 1 paper from summer 2023. This paper is worth 120 marks in total, and this is the third video of 6. It will focus on questions 10 to 13, which account for 19 of these marks. Eduqas Component 1 papers are non-calculator, so a calculator should not be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 10. In an athletics club, 20 of the female athletes have a mean height of 170 centimetres. 30 of the male athletes have a mean height of 180 centimetres. What is the mean height of these 50 athletes? So what's the mean heights of all of these combined? Now, it's not as simple as just adding those two means together, okay? It doesn't work that way. So we're going to have to reverse both of those mean calculations and take it from there. So we want to get the total height for females. So the total height for females would be the mean multiplied by 20, because what we would have done to calculate this was add them all together and then divide by how many we have. So to reverse that, we're going to multiply by 20. So 170 multiplied by 20. So 17 times 2 is 34. So the total height of the females is 3,400 centimetres. Okay. We also need the total height of the males. So we're going to reverse their mean calculation. So that would be 180 multiplied by 30. 3 times 18, well, that's 54. So it's 5,400 centimetres in total for the males. So now that we have their total heights, we're going to find the total height of all 50 people, because we've got 20 females, 20 males. So total height of all is going to be 3,400 plus 5,400, which is 8,800 centimetres. So that's the total height. There are 50 people in total. We're wanting the mean of those 50. So we're doing 8,800 divided by 50. So 8,800 divided by 50. Now I'm going to divide the top and the bottom by 10. So now I'm doing 880 divided by 5. You can do whatever calculation method works for you. This just works better for my brain, knowing that I can check it out as a fraction first, simplify it as far as I can, and then move it into a division calculation. So 5 into 8 is 1, remainder 3. 5 into 38 is 7, remainder 3. And 5 into 30 is 6. So the mean height of these 150 athletes is 176 centimetres. Part B. A boat crew has 8 rowers and a cox who steers. The heights in centimetres of the 9 people in the crew are as follows. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 heights of these people given here. The mean of these heights is 190 centimetres. Explain why the mean is not the best average to use for this data set. So what I'm going to look at and see is, do they all follow the same trend really? Because the mean is quite fickle. It can be affected by any extreme values. So if there's anyone that's a lot shorter than the others or a lot taller than the others, that can affect the mean. So it's not always the best average to work with. So I'm going to look at this, and so we've got 193, 188, 200, 198, 203, 201. So all of these are quite big heights, but then 150 stands out for me, because 150 is a lot smaller than all of these heights. So I'm going to put that the mean is affected by, let's call them extreme values, outliers maybe, you might have heard that word. And the reason why I'm saying that is because 150 is much smaller than the others. And that's the explanation I'm going to give. So the mean's affected by outlier values, by extreme values, and 150 is much smaller. So that's going to sway the mean. Question 11. The table shows some information about the cost per person to take a boat across the river. So adults in pounds is A, children in pounds is C. So the Jones family, so they've got 4 adults and 1 child, pay £9.50 to take the boat. The Patel family have 5 adults and 2 children, and they pay £13 to take the boat. Now the Lee family has 3 adults and 2 children. How much does the Lee family pay to take the boat? And you must use an algebraic method and show all your working. So we can't use trial and error here, guys. They've told us specifically to use an algebraic method. So what they've given us is the combination of adults and children for 2 families and how much it cost. So I'm going to form 2 equations, okay? 2 simultaneous equations, one for the Jones family and one for the Patel family. So for the Jones family, we've got 4 adults. Well, they say that adults is A. So we have 4A plus 1 child. So plus 1C. You can write the 1 in front of C if you want to. It doesn't make any difference. But they pay a total of £9.50. And then the Patel family have 5 adults. They have 5A plus 2 children. So 2C. And they pay £13 in total. So now we have 2 simultaneous equations, and the reason why we can treat them as simultaneous equations is because the price that the adults pay and the price that the children pay will be the same for the both families. It's a standard rate. So A and C values will be the same. So those equations are simultaneous equations. So what I need to do now is solve them. So to solve them, I'm going to make one of the variables match. So I'm going to label these equation 1 and 2. I'm going to multiply equation 1 by 2. Because when I multiply equation 1 by 2, I'm going to get 2c, which means it will match the 2c here on this equation. So when I multiply this equation by 2, everything gets multiplied by 2. So 4a multiplied by 2 is 8a, plus c multiplied by 2 is plus 2c, and then it equals £9.50 multiplied by 2, which is £19. Okay, I'm keeping equation 2 as it is because I was aiming to get a set of variables matching either A's or C's, and I've managed to match the C's. It doesn't matter if the signs don't match, it's the coefficient that's important. So now I'm going to solve these simultaneous equations. So these simultaneous equations, because I've changed this one to make it work for us. So I'm going to look. So I've got plus 2c plus 2c. So I'm working on eliminating a variable. So if I want to eliminate c, the variable that I've made have the same coefficient, I'm going to have to subtract these equations. Because 2c subtract 2c would eliminate it. So when I subtract these equations, I'm just going to treat it like a column subtraction, just to organise my working. So 8a subtract 5a is 3a, 2c subtract 2c eliminates my c variable, which is what I wanted, and then 19 subtract 13 is 6. So now here we're left with a one-step equation that's only got the a variable. So here we can solve for the price of an adult ticket to go on the boat. So 3a means 3 multiplied by a. The inverse, the opposite of multiplying by 3 would be to divide by 3. Remember, when we're solving, we're working on isolating that variable. So we have a equals, we have to do the same to both sides. 6 divided by 3 is 2. So the price of an adult is £2. Now we can use that price of an adult to work out the price of a child. So we can substitute this value back into one of these equations and then solve it for C. So I'm going to use this equation here. So I'm going to use the Jones family equation. So 4a add C equals 9.5. We know that A is 2, so 4 multiplied by 2 add C is 9.5. Well, that's 8 add C is 9.5. Remember, we're trying to find out the cost of a child, so we're solving for C. So we want to isolate the variable C. We want it to be C equals. So we need to eliminate this 8 on the left-hand side. The opposite of adding 8, because that's a positive 8, would be to subtract 8. So when I subtract 8 on the left-hand side, I'm left with the variable C. When I subtract 8 on the right-hand side, I'm left with 1.5. So the cost of a child is £1.50. Now, we haven't finished there. We need to find out how much the Lee family pay, okay? That's what we're aiming for down here. So we know the cost of an adult now, and we know the cost of a child. So for the Lee family, they tell us that they have 3 adults plus 2 children. So 3 adults. So the adults are £2, and then 2 children. The children are £1.50. So 3 times 2 is 6. 2 times £1.50, so 1.5 is 3. 6 plus 3 is 9. So the Lee family pays £9 in total to go on the boat. Question 12a. Circle the equation of a line parallel to the line y equals 4x add 5. So if lines are parallel, they have the same gradient. Okay, and when we're working in the form y equals mx plus c, m is your gradient. So the gradient of this line is 4. So we need to circle the equation of a line that also has a gradient of 4. So this equation has a gradient of -1/4. We're not going to include that one. This equation has a gradient of 4 because the m value is 4. So we're going to circle that one, but let's check the others just to be safe. Well, that's got a gradient of -4. That's got a gradient of a +1/4. Now this one is a little bit trickier. We need it to be y equals mx plus c. So I would have to divide by 4 to isolate that y. So when I divide by 4, that's going to be x over 4. So that's going to have a gradient of 1/4. So it's definitely this one. Part B, the gradient of the line which passes through, so we're working with the gradients. The gradient of the line which passes through the points A3 and 2A9 is 3/4. Find the value of A. Okay, so when we're working with the gradient, we do the change in y, so y2 subtract y1, divided by the change in x, so x2 subtract x1. So this is our x1, y1, and this is our x2, y2. So they should equal 3/4. So let's substitute in what we know for now. So y2 is 9, so that would be 9 subtract y1, which is 3. And then on the bottom, x2 is 2a, subtract x1, which is a. So 2a subtract a. Let's simplify this to get an expression for the gradient of this line. So 9 subtract 3 is 6, 2a subtract a is a. So 6 over a is the gradient, but they tell us that that should equal 3/4. Okay, so now we need to look at what's happening here. I need to find out what the a value is. Now working with fractions makes this a little bit simpler because we can see if these fractions are equivalent, if they've been scaled up or scaled down. Now looking at this 3/4, I can see that 3's been scaled up by multiplying by 2. So the same thing should happen to the bottom of the fraction. So when I multiply 4 by 2, I get 8. So a must equal 8. (13a). Find the next term of the following Fibonacci type sequence. So we've got a sequence here, 0, 2, 2, 4, 6, and it wants the next term. Now the important thing to note here is it tells us it's a Fibonacci type sequence. So it's one of the special sequences that we need to know about. So to generate a Fibonacci type sequence, you add the previous 2 terms together to get the next term. So 0 plus 2 gives us 2, 2 plus 2 gives us 4, 2 plus 4 gives us 6. So to get this term, we need to do 4 plus 6. So that next term is 10. Okay, part 2. Here are the first 4 terms of a sequence. So we have root 3, 1, 1 over root 3, 1/3, and then we've got 2 terms missing. It wants us to find the 6th term of this sequence, and it wants us to simplify our answer. So we've got term 1, 2, 3, 4. We need term 5 and term 6. So we need to find the ratio between these terms. So the ratio to get from one term to the next. So to do this, okay, I'm going to take this term, I'm going to divide it by that first term, or the term before it. So the ratio is 1 over root 3. So what we've done is, if we multiply each term by 1 over root 3, it will generate the next term. So let's check this. 1 times 1 over root 3 becomes 1 over root 3. 1 over root 3 times 1 over root 3 becomes 1 over root 9, which is 3. So we know that that ratio works. So I'm going to multiply 1 over 3 by 1 over root 3, this ratio. So that becomes 1 over 3 root 3. So 1 over 3 root 3 is my 5th term. I now need to multiply 1 over 3 root 3 by 1 over root 3, which becomes 1 over 3 times root 9. Root 9 is 3, so that becomes 1 over 9. So the 6th term is 1 over 9. Okay, part B, find the nth term of the following sequence. So when we're finding the nth term of a sequence, the first thing we need to do is find the difference between the terms. Okay, we want that common difference to get from one term to the next. So from -3 to 0, we add 3. 0 to 5, we add 5. 5 to 12, we add 7. 12 to 21, we add 9. So that first difference isn't the same. So we need to continue now and find the second difference. So that's the difference of the differences. So from 2 to 3, we add 2. 5 to 7, we add 2. 7 to 9, we add 2. So the second difference is 2. So this is a quadratic sequence because the second difference is the same. So for a quadratic sequence, to find our n squared term, we half the second difference. Half of the second difference is 2. So we're starting with n squared. So what we need to do now is compare this sequence with the sequence of squared numbers. So 1 squared would be 1, 2 squared would be 4, 3 squared would be 9, 4 squared would be 16, 5 squared would be 25. Okay, so first term, second term, third term, fourth term, fifth term. Now I'm going to see what's happened to get from the square numbers sequence to the sequence, the original sequence. So what do I need to do to make this into this? Well, to get from 1 to -3, we've subtracted 4. To get from 4 to 0, we've subtracted 4. From 9 to 5, we've subtracted 4. 16 to 12, we've subtracted 4, and 25 to 21, we've subtracted 4. So we've subtracted 4 every time, so I can simply write that the nth term of this sequence is n squared subtract 4. If I wasn't doing the same thing to get from the squared number sequence to the sequence that we're dealing with, if it was a different number each time, there'd be additional steps. But for this one, the answer is n squared subtract 4.